Okay, so the next question that we have is question number 10. And the question is, let A be equal to, we have some set A which is equal to R minus the set containing the element 3, and we have some set B which is equal to R minus the set containing the element 1, right? Now you have some function here which is a function from A to B, which is a function from the set A to set B, which is defined by basically f of x is equal to x minus 2 over x minus 3, right? Now we want to know if f is 1, 1 and onto, so we want to know whether f is 1, 1 and onto. So in order to basically check whether f is 1, 1 or basically injective, we need to make sure that for every A and B belonging to the domain, if f of A is equal to f of B, that implies that basically A is equal to B. That is the condition. So, which means that basically if let's assume that f of A is actually equal to f of B. And we want to prove this statement here. So if I assume that f of A is equal to f of B, then what that means is that basically based on the rule of the function, f of A is going to be equal to A minus 2 divided by A minus 3, and that is equal to f of B, which is B minus 2 over B minus 3. Now over here I need to, if I can prove that A is equal to B, then that means that this condition is met, and therefore the function is 1, 1 or injective. So now if I cross multiply here, I'll get A minus 2 times B minus 3 is equal to A minus 3 times B minus 2. Which means that AB minus 3A minus 2B plus 6 is equal to AB minus 2A minus 3B plus 6. These you can cancel out, AB and AB you can cancel out, and so you have 3A minus 2B is equal to negative 2A minus 3B. If I take my a's to one side, 3A plus 2A is equal to negative 3B plus 2B. Now, that's actually negative 3A. So negative 3A plus 2A is equal to negative A is equal to negative 3B plus 2 is equal to negative B. And that means that A is equal to B. So now here basically we have assumed that f of A is equal to f of B, and we have proved that A is equal to B, which means that basically f is injective. F is injective, or you can say that f is 1, 1. Now in order to show that f is surjective, what I can do is that basically I need to basically show that every element of I need to show that every element of the domain of the codomain of the function, which is the set B, is the image of some element in the domain of the function, which is A. So if I take f of x is equal to x minus 2 divided by x minus 3, if I take f of x is equal to x minus 2 by x minus 3, and let's take the output of the function f of x as, for example, y. So that means that basically y is equal to x minus 2 over x minus 3. Now let's see how we can find the inverse of this function. So that means that then basically y times x minus 3 is equal to x minus 2, which means that x times y minus 3y is equal to x minus 2, which means that if I take this x to the other side, that means that xy minus x, and take this to the other side, 3y minus 2, so xy minus x and 3y minus 2, and factorize this x, y minus 1 is equal to 3y minus 2, and that means that x is equal to basically 3y minus 2 over y minus 1. Right? So what that means is that now your x is equal to 3y minus 2 over y minus 1. Now over here we said that basically f of x is equal to x minus 2. F of x is equal to x minus 2 over x minus 3. Now since x is equal to 3y minus 2, I can write f of 3y minus 2 over y minus 1. 3y minus 2 over y minus 1 is equal to basically x minus 2 is equal to 3y minus 2 over basically y minus 1 minus 2, and this is supposed to be rather here, minus 2, and x minus 3, x is equal to 3y minus 2 over y minus 1 minus 3, right? So this means that this is equal to basically this is equal to LCM would be y minus 1 and 3y minus 2 minus 2 times y minus 1 divided by, again, LCM, I take y minus 1 and 3y minus 2 minus 3 times y minus 1. And then of course you can simplify these y minus 1 and y minus 1, and you will get basically 3y minus 2 minus 2y plus 2, and over here you will get 3y minus 2 minus 3y plus 3, and I might have made a mistake here. X minus 3, x minus 2, 3y minus 2, y minus 1, 3y minus y minus 1, minus 2, minus 3, okay. And then over here we have y minus 1. Over here we have y minus 1, so we have 3y minus 2 minus 2 times that's 2 times y minus 1. 3y minus 1 is 3 times y minus 1. And then I have here 3y minus 2 minus 2y plus 2. And over here I have 3y minus 2 minus 3y plus 3. And so what we get here is basically these two will be cancelled out. These two will be cancelled out. 3 minus 2 is equal to 1. And then over here you have 3y minus 2y is equal to y. So this is equal to y, right? So that means that f of 3y minus 2 over y minus 1 is equal to y, right? So what I did is basically I simply calculated the inverse of this function. So what this means is that for every y or every output of the function, basically if you input 3y minus 2 over y minus 1, that gives you any output of the function or any typical output of the function. Now what that means is that now here we are assuming that basically the input or the domain of the function is all the real numbers except 3, and the codomain of the function is all the real numbers except for 1. So which means that here basically every if you have basically any real number y, then 3y minus 2 over y minus 1 is of course going to be again a real number. There is basically you know that the set of real numbers are closed under multiplication, under subtraction, under addition, under division, and everything. You get whatever you do in the set of real numbers as far as the 4 operations are concerned: addition, subtraction, basically multiplication and division. You will again get the set of real numbers. Okay, and so here you can argue that, for example, let y belong to the set B, basically, because that is our basically our codomain. So let y belong to B, which is equal to, of course, r minus 1, right? So then you can say that y is not equal to 1, because over here we are saying that this set is r minus 1. So then if y belongs to this set, then of course y cannot be equal to 1, right? Now you can say that now that the function f is onto or surjective if there exists some x belonging to the set A such that f of x is equal to y, meaning that if all of these all of the y's belonging to B are images of some element in the domain of the function, then you can say that the function f is onto or surjective. So then you can say that the function f is onto or surjective if there exists x belonging to A, x belonging to the domain of the function, such that f of x is equal to y, right? Because y is the output of the function and it's some element belonging to the codomain of the function. Now, based on that, you can say that f of x is equal to y. That means that we said that basically f of x is equal to, x minus 2 over x minus 3. X minus 2 over x minus 3 is equal to y. And then if you go with this, if you do the algebra here, you will again get over here, that you will again get to these, get to the algebra that we did over here, and then you will have x is equal to, basically 2 minus 3y over 1 minus y, right? Because over here what we got was 3y minus 2 over y minus 1. Multiply the numerator and denominator by a negative 1, you will get the same thing, right? And which, of course, you know that this does belong to A. Of course, you know that y is not equal to 1, as we argued before, and this does belong to A because it's a real number. And it's a real number, and if this is A basically is all the real numbers except for 3. If y is not equal to 1, then any other number except for 1, then how can you make sure that this number is well, it doesn't really matter if it's not equal to 3. That's not a problem right now. But then this does belong to set A, because it's a real number. Whatever value you choose for y except for 1, it's going to be a real number. And so then you can say that, of course, for f of basically 2 minus 3y over 1 minus y is going to give you a y. That means that for every y there is, meaning that every y is the image of some real number in the domain of the function. Thus you can say that for any y belonging to the set B, there exists 2 minus 3y over 1 minus y belonging to the set A, such that f of basically 2 minus 3y over 1 minus y is equal to y, right? And of course we did the algebra over there, as you saw somewhere over here. We said that basically f of this is equal to f of this whole expression is ultimately equal to y, right? So then you can say that based on that, you can say that therefore f is surjective or untrue. So then basically the function is injective and surjective, right? Now, the next question that we have is question number 11. It's a multiple choice question. You want to know, basically we have a function, this is question number 11. You have a function f from R to R. You have a function from R to R defined as f of x is equal to x raised to the power 4, and you want to choose the correct answer. The first choice is f is 1, 1 and onto. F is 1, 1 and onto. Choice B is f is many 1 and onto. F is many 1 and onto. Choice C is f is 1, 1 but not onto. F is 1, 1 but not onto. And choice D is f is neither 1, 1 nor onto. F is neither 1, 1 nor onto. So the function that we have, I don't want to get into basically proving and everything, but you know that basically the function is x raised to the power 4 is some function like this. It's some function like this, right? Now, this function is basically, you know that f of x is equal to, if you graph this function, what you will get is that if f of x is equal to x raised to the power 2, you can see that you will have some function like this. It's a parabola. If you graph x raised to the power 4, the function changes a little bit. It becomes a little bit flat on around the x-axis, but then it's essentially the same thing, meaning that the range of the function does not change. The range goes from 0 to infinity, and that's basically the function that you have. So as you can see, basically the domain of the function is the set of real numbers. The range of the function is the set of real numbers. And of course, as you can see, for example, since f of x is equal to x raised to the power 4, then for example 1 raised to the power 4 is equal to 1, and negative 1 raised to the power 4 is again equal to 1. So f of 1 is equal to 1 raised to the power 4, which is equal to 1, and f of negative 1 is equal to negative 1 raised to the power 4, which is again equal to 1. Which means that f of 1 is equal to f of negative 1 is equal to 1. F of 1 is equal to f of negative 1, which is equal to 1. And so that means that, let's say, f of x1 is equal to f of x2, but x1 is not equal to x2, right? So that means that f is not injective. It's not injective, or it's not 1, 1. So that's about 1, 1. And you can see that the codomain of the function is the set of real numbers, and but there is, for example, this element over here, for example, negative 2, let's say. Negative 2 is not mapped to anything, because the range of the function is all just simply all the positive numbers. The negative numbers are not covered, which means that negative 2, you can say that negative 2 belongs to the set of real numbers, but basically there exists no element x belonging to the set of real numbers such that f of x is equal to x raised to the power 4 is equal to -2. And basically that's in simple language, -2 is just simply not the image of any element in the domain of the function, and therefore f is not surjective or onto, which means that the correct answer here is f is 1 1, but f is neither 1 1 nor onto. Choice D. Choice D is the correct answer. Choice D is the correct answer. And we have one more question here, question number 12. Question number 12. Okay, so let me 180. And you have a function f from R to R, and which is defined as basically f of x is equal to 3x. Now you want to choose the correct answer. Answer A is basically f is 1 1 and onto, is 1 1 and onto. Choice B is f is many 1 and onto, is many 1 and onto. Choice C is f is 1 1 but not onto, is 1 1 but not onto, is 1 1 but not onto. And choice D is neither 1 1 nor onto, neither 1 1 nor onto. Okay, now f of x is equal to 3x is some function like this, meaning that you have 1 1 2 and 3, and the function is basically a straight line. This is y and this is x. This is a straight line with a slope 3. Now what we have here is that basically what we have here is a straight line. As you can see, the domain of the function is the set of real numbers. The range of the codomain is the set of real numbers, and of course the function is 1 1 because any element that you can see here is mapped to some element in the codomain of the function, and by the same logic you can say that it's also surjective or onto. Now to prove that basically you can say that let sum, for example, a and b, let, for example, f of a be equal to f of b, right? So if f of a is equal to f of b, that means that 3 times a is equal to 3 times b, which means that a is equal to b, which means that basically f is injective. F is injective or 1 1, right? And moreover, you can say that basically since since basically you can say let y belong to the set of real numbers, or basically the codomain of the function, and therefore if y belongs to the set of real numbers, which is basically some element of the codomain of the function, then you can say that f of x is equal to y, which means that f of x, since f of x is equal to 3x is equal to y, which means that x is equal to y thirds, right? So which means that basically now if you calculate f of x is equal to 3x over here, since we have f of x is equal to 3x, now since x is equal to y thirds, you can say f of y thirds is equal to 3 times x, which is equal to 3 times y thirds, which is equal to y. So f of y thirds is equal to y. That means that for every y belonging to the set of natural numbers or codomain, there exists some y thirds belonging to the domain of the function, such that f of y thirds is equal to y, right? You can say that for every y belonging to the set of real numbers or the codomain of the function, there exists y thirds belonging to R, or to the domain of the function, such that f of y thirds is equal to y. And therefore f is surjective, or basically you can say unto, right? And so what that means is that f is 1, 1 and unto, the choice A is the correct answer. Okay, so this was all of the exercises that we had here. This was exercise 1.2. So in the next video we will talk about composition of functions and invertible functions. I'll see you in the next video, and thank you.